Where's everybody? I guess they're held up by that snowstorm out there. Hi, good morning, everybody. I'm getting all choked up over it. Anyways, good morning. Important thing I'd like to discuss real quick is safety consideration, and that is the fact that now that warmer weather should be upon us soon, it's still, remember, for the lab that you shouldn't wear any open midriff in the lab. Not that I'm a prude. In my class, you can wear anything you want here. It's legal in the state of Illinois, city of Elgin, and on this campus. I don't care. But in the lab, open midriff, also spaghetti top, that's not protecting you. Also, those of you who have lab tomorrow, don't forget, you need to wear a long sleeve top or a lab coat. All right, yesterday I ended up just showing you the slide, and we were talking about esters. What is an ester? An ester is a carbonyl, carbon double bond to oxygen, with the carbons attached to it are an oxygen bonded to that same carbon, and on this oxygen you have other carbons, and this is an ester. And as I mentioned yesterday, esters are responsible for many of the tastes and odors of things in your life that are good, such as all flowers. When you smell a flower, like a rose, what you're really smelling is an ester, or a mixture of esters. When you taste certain vegetables or fruits, or smell them, what you're really smelling or tasting is an ester. Let's go out in the real world for a second. I showed this to you. I don't think I did. If I did, someone told me no. And don't write these down, but these are various esters that have very distinct fruit or vegetable, or in vegetables or fruits. And let's look at one. Oh, let's come down here. If you look at this one, isobutyl acetate, it's in cherries, raspberries, strawberries. This complex ester, actually it's not really, yes it is. Ester is in apple and peach. Glue is not a vegetable. I don't know why they have that in that. But if we look down here, things like strawberry, methyl, this ester, and you can't see it, but these two esters right here are responsible for the flavor and smell of oranges. So when you go out into the real world, what I'm teaching you in here is really there. And that's the exciting part of organic chemistry. It's everywhere. It's in your life. All right, let's get back to the actual reactions. And remember, these reactions are like learning things in math, like how to add, subtract, divide, etc. And it allows you to do a lot of things, or as a carpenter who learns how to use a nail, a screw, a 2x4, other things like that. And what can they do? Build things that we use in our daily life. And organic chemists use these reactions to build things. All right, how do you make an ester? You react a carboxylic acid. Remember, esters are derivatives of carboxylic acids, are made from a carboxylic acid with an alcohol in the presence of acid, H+. And for those of you at lab yesterday, you learned that acid is usually sulfuric acid. For those of you at lab tomorrow, you'll learn that acid is sulfuric acid. And what you get is an ester. For those who must, this is one of my rare times I'll do it. You also get water. In case you're wondering where does the rest of the stuff go, it goes somewhere. And Since in the past I've had students get upset when I don't put that up there, I don't need any upset with students today, so I'll put it up there. All right, important thing. The carbon in the alcohol with the hydroxyl group is the carbon bonded to the oxygen and R prime in the ester. Let's do one. And if we look at the following reaction, the question is, give the organic product or products for the following. How do you do that? Well, you identify the functional groups. Then you play that fun game, circle and name the functional groups, but you don't really have to circle them, and you look for what's different. I have two oxygens here, carbonyl hydroxyl group on a carbon, carboxylic acid. This is my R group. Hydroxyl group on a carbon, alcohol. This is my R prime. Being a carbonyl synthetic organic chemist, I'm going to keep my eye on the carbonyl carbon, because that's where the action is, becomes this carbon. So if we look at this carbon right here, I'm going to draw that first. And then whatever's attached to it, R is still attached to it, because you know you don't break carbon-carbon single bond. And then I'll have my oxygen. And what is R prime? 3 carbons. Which carbon has the hydroxyl group? Oxygen, the center. So that will be the center one here. And that's the ester you make. And why don't you try this one for your fun and enjoyment on this sunny morning? Carbon has just gone down. All right, let's take a look at this and how do you determine what's the product or product following reaction, and that is what's different, what functional group am I dealing with? Oxygens, carbonyl hydroxyl group, carboxylic acid, and alcohol. Acid catalyst, and what do I get? An ester. Again, this is Fischer esterification, discovered by the great German organic chemist Emil Fischer, this alone would be a lifetime achievement, but he's more known for his work with sugars, which we'll talk about later. What's my R group? These 3 carbons. What's my R prime? 3 carbons. And now we look at this and say, keep your eye on the carbonyl carbon, because that's where the fun is. And what's ever attached to it, I'll draw that first, is still attached to it. What's R? 3 carbons. What's R prime? 3 carbons. But notice the hydroxyl group is on the N carbon, Therefore, this oxygen will be to the N carbon on 3 carbons. And I have some hydrogens included here. Remember, it's your solemn responsibility, being a student in my class, if I make a mistake, correct me. And that's the ester you have. Oh, let's do one more. These are fun. And why don't you try this one? But before you do, let's take a look at something. Notice this molecule right here has 2 functional groups. And I would ask the question, does anybody here know a reaction with a carboxylic acid and a benzene ring? Because I don't, so it doesn't react. All right, from the look everybody's giving me, get moving. I better get moving. So I will. If we look at this, what's different? Carbonyl hydroxyl carbons, carboxylic acid. Benzene ring, but that's not going to react with it, so that's really an alcohol. Hydroxyl group on carbons, alcohol. Acid catalyst. I'll make an ester. What's my R group? What's attached to the carbonyl? And that's where you keep your eyes on, because that's where the fun is. And here's my alcohol, and I'll call the benzene ring R prime. I'm going to write my carbonyl first. What's attached to it? 2 carbons. Oxygen. What's R prime? My benzene ring, and I just made this ester. Now, on test number 3, like test number 2, I'll have some synthesis problems. Oh, tell them to sell. Must be my stockbroker, because he couldn't get through on my phone. Sell. Sure wasn't President Trump. And the question is, how do you make a compound synthesis? Now, if we look at the following, the question would be, what would you start with to make the following molecule? And the question is, well, how do you do that? Because I'm sure all of you want to get points all you can on a test, and I want you to learn how to do synthesis. So let's look at this. What's different? Carbonyl, oxygen, the carbonyl. Carbons here and here, ester. What do I react to make an ester with acid catalyst? A carboxylic acid plus an alcohol. What's R? Oh, in this case, methyl. What's R prime? Methyl. So if I come back here, first question mark, doesn't matter which order you do it, there'll be this carboxylic acid. My alcohol, what's R prime? Methyl. And if you react these together, you'll make that ester. And I'll let you try that one on your own. What would be the starting materials, two of them, that you would use to make that molecule? I won't even give away what functional component that will. Makes me so happy to see everybody jumping in and doing synthesis. Light sky. It looks like just about the last hydrant went down. Let's take a look at this. And the question you have to answer is, what functional group am I dealing with? What's different? Oxygens should get your attention like that. I have carbon double bond to oxygen, carbonyl. That same carbon has an oxygen. On the carbonyl carbon, you have carbons. And on the oxygen, you have carbons. I'll call them R and R prime. That's an ester. How do you make an ester? From a carboxylic acid plus an alcohol. Now if we come over here, what's my R group? The carbon's bonded to the carbonyl carbon. What's my R prime? The carbon's bonded to, you see that? To the oxygen here. And if I come back here, what's R? Two carbons. My carboxylic acid. What's R prime? Oh, my favorite T-butyl group. And this carbon that's bonded to the oxygen there will have the alcohol. And that's the molecule you get. And that's how you make esters. And for those of you who had lab yesterday, you learned, and those of you who have lab tomorrow, you learned, organic chemists or companies make a lot of esters. And one group that they're used for is what we call artificial flavors. Instead of going and finding something like a cherry flavor or apple flavor, you see on a box of, for certain product, artificial flavors, they made that ester in a chemical plant and put it in there. I don't know if I told you, there's two types of grades of chemicals. One is called industrial, the other is called food grade. Industrial chemicals have different purity. How much do you want to pay for how pure it is? Usually most of them are very pure. And then food grade, not only are they extremely pure chemically, they're extremely pure biologically. In other words, they don't have any microbes or other goodies in there now well beyond my level of expertise, because I've never worked with food grade chemicals. I've been in a plant where they do, and it's quite interesting, but firsthand, no. And that's how you make esters. For those reading the book, I'm skipping the mechanism of Fischer's purification. All right. In the past, I just briefly mentioned this, but I've got to do more than just briefly mention it now because of the ACS test, and I'll explain why in a second. Now, unlike carboxylic acids, you can have cyclic esters. And cyclic esters have their own name, even though they are esters as a functional group, people call them lactones. How that came about, I don't know. Lactones is not really a functional group, it's just the name of a cyclic ester. I will not ask you to name cyclic esters, even though there are AUBEC rules how to do that. But let's take a look at this, which I do it that way. Same thing, I'll just rotate it 60 degrees. Both of these are the same, but since I have it on the slide, I'll do it that way. How do we know this is an ester? Good question. Well, I've got a carbonyl, carbon, double bond to oxygen. I have an oxygen here. So I have a carbonyl, this right here. I have this oxygen right here. It's got carbons here, I'll call that R prime. And this carbonyl carbon has carbons, I'll call that R. But it just so happens R and R prime are connected together in the ring. This is an ester. Now, the reason why I'm showing you this is because just about every ACS test. By the way, how many of you took 1211 here and took the ACS final there? How many thought it was a fair, easy test? How many thought it was a fair test? I already knew that. I taught, it's been many, many years since I taught 1211. I stopped teaching it because we have to get the ACS test. It's not a good test. But the 1212 test, well, it's better, but it still has its, how should I say, limitations. I'll talk more about that in the end of the semester. I'll give you some hints how to do well on that. Historically, my students do well above the national average. Usually what they get on my test number 5 is what they get on the ACS final, which I was quite surprised and pleased because I wasn't sure how good. Because I've met some people who write questions for those finals, and most of them are trying to impress other people who write questions. Look what kind of questions I can write. And now I have to show you about one that I now do put on my test. In the past, I never did. But since this is always on the ACS, this is another area that I'll talk about later, I need to go over. And on the ACS test, you might see a question like this, and the same thing on my test now, to prepare you for that. And the question is, what's the organic product or product? And you look at that, most students get it wrong. Let's work through this. What functional groups are in this molecule? Ooh, oxygen's here. Carbonyl, hydroxyl carbons, carboxylic acid. At this end of the molecule, what functional group do I have in here? Carbon, hydroxyl group, alcohol. If I react the two together, because they're in the same molecule with acid, what will I get? An ester. Now let's take a look at this. If we look at this molecule, 1, 2, 3, 4, 5 carbons, and then notice the oxygen, when we react this with this, will be bonded to there. So let's call this 6. Now, if I react this hydroxyl group with this carboxylic acid, or that alcohol, that oxygen here will be bonded to the carbonyl. this oxygen. So how can I draw that? One way. This oxygen here will be bonded like that, which nobody ever draws it that way. Let's count how many atoms are in a ring. 1, 2, 3, 4, 5, 6. And notice if I call this the carbonyl, if I put it up here or here, let's put it there. What's attached to it here? The oxygen. And we'll learn later, these are called heterocyclic compounds. Hetero meaning different, and what we're talking about, different atoms in a ring, not all carbon, and this is a lactone. And they put this on the ACS, and I'm showing it to you because I now have to put usually something like that or another problem on my test number 3 to help you prepare for that. And why don't you try this one? What would be the product or products for a following reaction? And unfortunately, the ACS being multiple choice, you'll see a number of different ones. But usually the good thing is the people who wrote the test were nice enough that if you really look closely, you can see only one answer is really obvious if you know what you're doing. Let's take a look at this. And the question is, what's the product or products of the following? And let's look at what's different. Carbonyl hydroxyl group, carboxylic acid. Carbon with the hydroxyl group, alcohol. Acid catalyst, and that is the reaction Fischer esterification to make an ester. And now if I look at this, I say, well, here's my carbonyl carbon, and here's my alcohol, so this oxygen will bond to that carbon. And this is what I'm going to have, but nobody would draw it this way. I have 1, 2, 3, 4, plus the oxygen, 5 atoms in a ring. You could draw it that way, or you could also draw it, and all I'm doing is rotating it that way. And you get this lactone. And these are some problems I can now put on my test, number 3, and the ACS usually has this one or similar, and then there's another case of a heterocyclic compound I'll talk about when we get into amides, that they also, one of those two, since the last 5 years, every semester has been on one of the tests I give. And I'm telling you that because I don't think it's a fair question for this class, so that's why. Now, another interesting thing I should point out, in organic chemistry, you've learned this semester, are a lot of interesting molecules that do good. Sometimes there are molecules that are not good in certain applications, and this is one of them. This molecule, and it's ester, which you can convert back to that, and I'll teach you that later, is quite a serious, dangerous molecule. And it's used in the wrong way. And the name of that is gamma hydroxybutyric acid. And that's a common name. And it also goes by the acronym GHB. GHB is also known as the date rape drug, which I think you're familiar with if you followed the news in the last 10 years. People would put it in somebody's drink, it would affect their memory. I have no idea, because this is not an area in all, I should say, first-hand experience, and never will. But I read from what in the newspapers and TV, and then the obvious happens. Now, interesting thing, I worked for a company that used this ester, lactone, for a catalyst in certain reactions we did. And we used to have in our plant, which was located right off Harlem and the Eisenhower Expressway, usually about 50 to 100 drums located on site. And for the date rape drug, you only need a few 50, 100 milligrams of damage. And about the time I was working there, the EU, European Union, outlawed this drug. And our company was saying, we've got to switch to something else because we've got so many drums on hand. We're lucky nobody has stole it or tried to steal it. And about 2 years, 3 years later, the EPA or the federal government here also outlawed use of it. And they're good uses, and like I said, bad uses. Well, now that you have an ester, what are some good things you can do with it? Well, guess what? You can react it with acid and water and hydrolyze it. And what this does is gives you back the carboxylic acid and the alcohol you would have used to make that. Now, I have it written that way. I can also write it this way. I could also write it this way. Either this way or these two ways means you take an ester, react it with acid and water, and what do you get back? You get back the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. Take this molecule and react it with acid and water, the question would be, what's the product or products do you get? And in this case, you're going to get two of them, because what's this? What's different? Two oxygens, carbonyl with carbons, oxygen with carbons, ester. By the way, there's 1, 2, 3, 4 carbons in R prime, for those of you counting. Hopefully all of you. This is my R group. This is my R prime. And therefore, if I look at this and say, what do I get? My ester, I can keep my eye on the carbonyl carbon, and that becomes this carbon right here, which I'll put first. You don't have to, but I usually do. What's attached to it? Double bond oxygen, R group. What's my R group? 2 carbons. Why? Because you know you don't break carbons up in single bonds. It comes along for the ride. And next, my alcohol, R prime. Now this is important. The carbon bonded to the oxygen in R prime is the carbon the hydroxyl group will be in the alcohol. Therefore, we have 4 carbons, the N carbon, And those are the two products I will get. Again, the carbon in R prime bonded to the oxygen will be the carbon in the alcohol R prime here that has the hydroxy group. In this case, it's the N carbon of 4 carbons. If I needed to find acid and water real quick right now in this room, where would I find it? My stomach, or your stomach, so you have it. And we're going to be coming back later to this reaction. Why? Because when we get to fats and oils, you'll learn all fats and oils are esters. And if you had anything with butter in it or anything with oil in it in the last number of hours, in your stomach, the acid and water is breaking down the fat and oil to make carboxylic acids and alcohols that your body uses to build things. Now, maybe on that level of expertise, I understand the chemistry, but not the other things your body does with it. And we'll learn this is an important way of getting nutrition by consuming fats and oils. So just remember, your stomach is a walking chemical. You, in general, are a walking chemical plant, and there are lots and lots of chemical reactions going on in your stomach, also elsewhere in your body. And why don't you try this one? Question B, what's the organic product or products you're following? Remember when you're done, look up and give me the high sign. I'm done, or just a smile or something. All right, let's take a look at this. By the way, I have been secretly, and I've done it all semester, inoculating you against the chemistry instructor, and they also do it on the ACS final trick of putting something big and scary in a molecule so students get confused, but you shouldn't. I threw in a ring right here just to have some fun, which I did. Now if we look at what's different, oxygens, carbonyl, oxygen to the carbonyl, carbons here, I'll call that R prime, a ring, but that's just carbons. Ester, when you react it with acid and water, what happens? You break it back down to the carboxylic acid you would have used to make that, plus the alcohol you would have used to make that. What's R? What's attached to carbonyl, this ring. What's R prime? What's attached to the oxygen here. And now, what do you get? Start with the carboxylic acid. What's my R? A ring. Do you break carbon-carbon single bonds? No, that's an awful ring. Hold on. That's better. And then what's R prime? 2 carbons. The carbon with the oxygen will have a hydroxyl group. And that's what you get. Now, common mistake students do on something like this, they'll take this and write it like this. Anybody see something a lot wrong? 3 bonds to carbon, 5 bonds to carbon. Make sure you always have 4 bonds to carbon. This should be over here. One of the nice things, Mother Nature makes a lot of esters, and by knowing this reaction, you can make from those esters various alcohols and carboxylic acid, which not only organic chemists do, but your body does too. All right, here's a fun molecule. What's the organic product or products for the following? For those who came in late, remember tomorrow if you have lab, you need to wear a long sleeve top or lab coat. Also, don't forget, now it's getting warm out, I mentioned this early, but for those who came in late, no open midriff or spaghetti tops in labs either. Not that I'm approved, but it's for your safety. All right, let's take a look at this. Wow, a lot going on in this molecule. Got a benzene ring, got another benzene ring. Will that react with acid and water? And the answer is no. Therefore, what do we have? Oh, carbonyl, oxygen, carbons here. My benzene ring. On the oxygen, I have benzene ring. I'll call that carbons, R prime. And what you get is acid hydrolysis of an ester, which you get back the carboxylic acid I would have used to make that ester, plus the alcohol I would have used to make that ester. What's R? A benzene ring. What's R prime? A benzene ring. Therefore, my carboxylic acid, R is a benzene ring, and you get benzoic acid. R prime is a benzene ring, and you get this alcohol phenol. Now, I'm going to put a problem on the board. Do not be concerned if you have a lot of difficulty with this one, but this is something, again, I now put on my test, or could put on my test, because the ACS gives stuff like this. And why don't you try this one on your own first, and then I'll show you how to do it. Again, this is very difficult. Maybe for some of you, maybe not. That's a 5-member ring, and one of the atoms in the ring is oxygen. Came in late, didn't sign in, don't forget to sign in. Time flies when you're having fun with Esters. Hi. Let's take a look at this, because I think some of you are having a little difficulty. Question is, what's different here? Ooh, two oxygens. This oxygen, double bond to carbon. This oxygen to that same carbon, and it's got carbons on it. I'll call it R prime. This carbon, double bonded, my carbonyl carbon, has carbons here. I'll call that R. This is a lactone, but it's really functional group ester. What happens when you react an ester with acid and water? You get back the carboxylic acid plus the alcohol you would have used to make that. And if we look really, what are you breaking? You're breaking this bond. This gets a hydrogen, this gets a hydroxyl group. You're adding water, H here, OH there. So what you're really doing is breaking that bond. The carbonyl will get a hydroxyl group. 1, 2, 3, 4. 1, 2, 3, 4. The oxygen is atom number 5. And then you'll have on this carbon here a hydroxyl group like that. And if we draw this out, it really looks like carbonyl with a hydroxyl group. One, two, three, 4, and then I'll have my hydroxyl group there. And that would be the molecule. On a test, if you wrote it this way for my test or this way, it'd be acceptable. On the ACS, they're going to show it to you this way. And I'm warning you about it because I don't think that's fair to do problems like that. Quick reminder, when you leave my class today, and you happen to go home, if you happen to be in your kitchen and pick up a bottle of vinegar, remember the vinegar is acetic acid and water, which is a carboxylic acid. If you happen to go home and pick up a bottle of nail polish remover and look at that, and that has ethyl acetate, which is an ester. And I ask questions like that on the test. Give an example of a molecule with an ester or carboxylic acid. I'll let you do that. With that, I'm going to let you out a whole minute and 45 seconds early. So everybody, run away.